Alright, good morning everybody. Sorry I'm not there today, but I want to keep you up with yesterday's classes. So this is the PowerPoint from yesterday that we went through. Here are the four things that you're going to do today, which you've already done one of them, which is the error analysis. A reminder that the first page, ECAS number 4, the factoring, we are going to assess on week 25, which is next week. The exponentials will be assessed on week 26. So they're not retakes, but we're assessing you again because there's going to be a few new things that we're adding, a few new wrinkles to your factoring and a few new wrinkles to your exponents, which I'm going to start teaching you today. Alright, so that's a plan for this morning. The error analysis, I know we did the error, we found the error, you corrected the problem. Part C, the reflection part, this is where you really learn. You need to pinpoint that error, and then D, pinpoint what you have to do to not repeat that error. So pinpointing that error means, like somebody in seminar the other day was like, oh, I gave the answer to the cubic when the situation was a perfect squares. So what you need to do is pinpoint that. I need to remember or recognize the difference between a perfect square situation and a cube or sum of cubes situation. How you do not repeat that error is you practice that out. I'm going to practice factoring perfect squares and also practice the sum of cubes, and that way you don't have that error keep coming up. So you must practice those errors out. What we're going to do, or what I did yesterday, what you're going to do today, this is on homework number 2, is practice these exponential equations. Now, I want you to copy this down somewhere in your notes, a flip book if you can, but in your notes you should have these. So don't just watch. Copy these things down so you hear it, you write it, and then you do it. And then when you do the homework, you practice it. So all those different ways are going to help you to remember this. Alright, so let's try these two right here. Looking at the first problem there, 625 to the 1 minus 2v power equals 25 minus v. What we notice is that left and right are equal to each other. They don't look equal, but they are equal. What we want you to do is change the bases. You have 625 as a base and 25 as a base. Let's change the bases so they are the same. Can I zoom in? Let's pull this up. So they can be changed to be a base of 5. So 625 can be written as 5 to the 4th power. And then 1 minus 2v is your exponent. 25 can be rewritten as 5 to the, yep, you got it, 2nd power, all to the minus v. Okay? Now what we do is when you have an exponent on exponent, you multiply them. So this will be written as 4 times 1 is 4, 4 times negative 2 is negative 8, so you get 4 minus 8v. The right hand side will be 5 to the minus 2v. Alright, now our bases are equal. That must mean our exponents are equal. So not that the 5's disappear, but I'm going to focus in on the exponent. So we write therefore 4 minus 8v must be equal to minus 2v. From here you guys can solve it. You guys solve for your v, get them all to the same side and solve for v. So what you're doing is manipulating this to look like things you've already done before. Alright, the right hand side, 216 and 1 over 6, we're going to do the same thing. We're going to rewrite this with the same base. Might be a little tougher because you got a fraction, but you can still do this. We notice that both of them are forms of the number 6. 216 is 6 to the, 6 times 6 is 36, 6 to the 3rd power. 1 over 6 is 6 to the negative 1 power. Bam. And then we do what we did on the previous problem. Multiply your exponents. And therefore, since our bases are equal, our exponents must be equal. And then you guys solve from there. Whoops, whoops, whoops. What a mess. Okay, let's rewrite that again. Negative 9k equals negative 2k. Alright, from there you've got to figure that how to solve for k. You're gonna, and I'll show you really quick because some people had issues yesterday. Add that 2k to both sides, get negative 7k equals, yes, 0. And then you guys solve k from there. Alright, the other thing we covered yesterday, whoops, escape annotation. What the heck? Let's keep moving. Fractional exponents. Boom. Square root of x. So this is another topic. of our fractional exponents, and which means we're going back to, we're using our radicals. We're talking about square roots, but there's a whole world upon square roots that we need to get used to. So let's focus on the square root for a second. There's another way to write the square root of x, and that is, yes, you are correct, x, whoops, let me do this, x, whoops, x to the 1/2 power. So bam, we're back to using exponents. So what you're doing is translating from one to the other. So square root, change that to x to 1/2 power, and you can go back and forth on this. Whoops. No. How come? Shoot. Our next slide, square root of 9. Oh, this is going to be weird jumping back and forth. Let's see. Boom, boom, boom. Well, let's have all of them up. Oops. Let's have all of them up. Now let's write. Alright, so these are your notes. You should have all of these things in there. You're going to be practicing how to change them back and forth. 9, square root of 9 would be 9 to the 1/2 power. X cubed would x cube root of x. Cube root of x is going to be rewritten as x to the 1/3 power. Cube root of 9 can be written as 9 to the 1/3 power. Nth root of x, which means any number you put there, can be written as x to the 1/n. Alright, what you're going to have to do is be able to translate from back and forth. Now this last column is x to the 4/5 power. There are two ways to rewrite that. You can write it as the 5th root of x to the 4th power, or you can write it as the 5th root of x, all of it in parentheses, to the 4th power. That last one, I want you to rewrite it back into fractional exponents, which means you write it as 7 to the 4th 6 power, which then reduces to 7 over 2/3 power. Alright, so you have to know the two different ways to look at this. Either it's in exponent form, boom, here, well, let me do this. Exponent form, let's see, exponent form, or it's in radical form. Boom, radical form. Ooh, radical form. This is radical form. Everything in blue is in radical form. Everything in yellow is in fractional exponent form. And you guys got to get used to that. Okay? Alright, last thing is this. Factor all of these suckers. Try it. Go for it. Press pause. Go for it. And then press play when you're ready. Okay. Now that you're back, m squared minus 9 will be, whoops, let me go back. M squared minus 9 will be, it's perfect square, so m plus 3, m minus 3. M squared plus 4, when you factor that, is m squared plus 4. That is not m plus 2, m minus 2, or m plus 2 times m plus 2, because you will get, this one doesn't work. This one would give you m squared plus 4m plus 4. It would give you that unwanted, not unwanted, but really the middle term that is not a part of, what the heck? That's not a part of this right here. So this one is not factorable. So be careful. If you look closely, the pattern is if it's minus, you can factor it. If it's plus, you cannot factor it. Alright, here, x squared plus 5x plus 6, should be able to have gotten that one. That's x plus 3 times x plus 2. This one, x to the 4th power, what I'm saying here is that's factored the same way. It's a trinomial. It's like an advanced trinomial. Trinomial will mostly factor into two binomials, so let's try that. X to the 4th power will split into x squared and x squared. And then, since you have a 5 here, a 6 here, it'll be the same thing. X plus 3, x plus 2, and you factored, your way you factor this is just like the way we factored that. But it's got to be a trinomial. It's got to have an even number here, and this has to be half of that number there. So you could do x to the 6 plus 5 times x to the 3rd plus 6. You could do x to the 8th plus 5x to the 4th plus 6. Okay? That's called the quadratic form. It's not a quadratic, but it's in the form of a quadratic. Alright, good luck on that homework, and have a great weekend, and I will see you next week.